I'm going to go ahead and talk about the Pythagorean theorem and how it actually is an application of the square root property. And the way the Pythagorean theorem works is it shows the relationship that exists in a right triangle, meaning a triangle with a 90-degree angle, between the sides. And it is the case whenever you have a right triangle, a triangle with a 90-degree angle, the two sides that make up the 90 degrees, if you squared them and then added those squares together, so a squared plus b squared, it will always equal the square of the side opposite the 90, that is called the hypotenuse. That's just the name for that side that is opposite the 90-degree angle. So that would form a problem that can be solved by the square root property if one of those sides is unknown. For example, here, if I went and I tried to solve for x, as if this was maybe a truss that we were building and we knew this was a 14-foot measurement here and this went up 16 feet, we would want to find maybe what would this side have to be for that to be the case. Well, remember, it's the square of the sides that get added together, the sides that make up the 90-degree angle. So I'd have 14 squared plus x squared is always equal to the side that's opposite the 90-degree angle squared. And then I just solve this. I go ahead and multiply 14 times 14 to my calculator. Let's take a look. 14, and I could actually just hit the square button on these calculators. There's a square button right here. So 14 squared equals 196 plus x squared and 16 squared. Let's take a look what that is. 16 and squared. And that equals 256. So let's put that down over here. And what we do in solving a problem where the only variable in the problem is part of a square is I go ahead and isolate that square. So let me subtract 196 from both sides. I get x squared is equal to 60. And now, only because it's an application problem, after I take the square root, I'm going to do two things with this answer. Number one, I think I'll only worry about the positive answer because, practically speaking, this could not be a negative dimension. And then also, because it's an application problem, I'm curious as to how many feet this side has to be, and the square root of 60 doesn't tell me too much. So I'm going to go ahead and take the square root of 60 in my calculator. And I go ahead over here, and I'm going to need that second x squared feature of my calculator because where my square root is right above x squared. So to get to a feature on the face of a calculator, you have to hit second and then the button that is right below it. And so I'm taking the square root of 60, and I get 7.74. I mean, that's awful close to 7.75, which is 7 3/4 feet. 7 3/4 feet. So this would have to be 7 3/4 feet, which actually is, 3/4 of a foot is 9 inches. So this is really 7 feet 9 inches if we wanted to do that.